AI automation currently faces a ceiling caused by the friction of perception. While language models are highly capable, the difficulty of getting a system to simultaneously see, hear, and read creates massive operational friction. To process a complex task like reading a PDF while watching a screen recording, developers typically have to chain together a vision model for the video, a document model for the PDF, and a separate text model to synthesize the final output. This setup requires an orchestration layer to manage the data flow. Every handoff creates an API call that adds significant latency and allows context to leak out between the steps. This flowchart from NVIDIA illustrates the mechanical failure of this fragmented stack. You can see the separate inputs funneling into a red bottleneck labeled orchestration and fusion. Nemotron 3 Nano Omni is designed to collapse this entire chain into a single unified pass. Removing this perception tax is a requirement for building agents that can actually execute multi-step automation in real-time environments. The Omni architecture processes video, audio, text, and images natively and simultaneously. It doesn't rely on separate models or intermediary text translations to understand different media types. In traditional pipelines, the delay between a vision encoder and the language model can cause an agent to lose visual context. Nemotron ingests video frames directly alongside its text reasoning, keeping the visual data synchronized with the task logic. The model can ingest an entire 35-page PDF document at the same time it watches a video. It maintains every variable across both inputs in a single reasoning session. This fusion changes how an agent experiences data. Context is no longer reassembled from different sources. It is processed as a single coherent event. The engineering behind the model allows it to utilize 30 billion total parameters while activating only 3 of them at any given step. This is achieved through a mixture of experts' design. Instead of running every input through the entire network, the model routes tasks to specialized internal subnetworks to minimize the required compute power. These specialized encoders feed into the shared brain. On the left, the parakeet module tokenizes raw audio, understanding vocal tone and intent. The visual chain uses 3D convolution, fusing consecutive video frames to have the tokens required without losing temporal detail. This data flows into a 256,000 token context window. This capacity builds agentic memory, allowing the model to retain massive datasets and long video histories in its active reasoning space. This demonstrates that processing power is a result of optimized internal routing and specialized data sampling rather than raw parameter size. Benchmark data shows how this architecture performs against its closest open-source competitor, Quan 3 Omni. The green bars represent the high accuracy leads in the voice stench and video MME categories. Efficiency is even more pronounced in video workloads. This breakdown highlights a 9.2 times increase in video throughput compared to standard agentic pipelines. For a business, this multiplier changes the speed of operations. Processing a 1-hour recorded client presentation can now be completed in seconds rather than several minutes. These benchmark results represent a significant drop in the compute overhead typically needed for agentic workflows. The model operates effectively in human-centric environments. It can interpret the complex mood of a visual scene or generate functional code like this JavaScript and CSS for a Pomodoro timer with 0 external dependencies. NVIDIA has also made the supervised fine-tuning recipes fully available. Enterprise developers can use these to customize exactly how the model reasons and interacts with their specific business data. Deployment requirements vary based on precision. While the full FP16 model needs 61.5 GB of VRAM, the FP8 variant brings that requirement down to 32 GB. To make the model accessible for individual developers, NVIDIA developed a custom FP4 quantization format. This compresses the massive model down to just 21 GB, allowing it to easily fit on a single consumer-grade GPU. Nemotron 3 Nano Omni effectively brings enterprise-grade multimodal reasoning to local single GPU machines.